Hey guys, welcome to the show. Today we're checking out GLM-5. Number 5 is here up there with the GPTs in the world. Now GLM, in case you don't know, it stands for General Language Model, and it's known as one of the best coding models out there in the world. And z.ai, who make it, they've gone crazy. They have literally, almost doubled the number of parameters that they have. So previously they had 355 billion parameters. Now it's gone all the way up to 744. They used to do 32 billion active parameters. Now they've gone to 40 billion active parameters. They used to train on 23 trillion tokens. Now they've gone up to 28.5. So apparently it's going to be the best thing since sliced bread. They've integrated DeepSeek's sparse attention. So that means it should be able to handle super long context. And we also got multi-head latent attention. So that means our memory usage has shot down compared to what we were doing previously with some major optimizations, 3x memory improvements. And this gets applied to GLM, it gets applied to DeepSeek, and it gets applied to Kimi K2.5. I'll show you all the demonstrations as well. But let's just look at the benchmarks. Look at this right there, GLM. We're going to go into coding strategy, software engineering bench, 73.3. It's better than GLM 4.7. That was abysmal at 66.7. Everyone said that was the best coding model, and it's only 66. But now it's gone to 73.3. It beats DeepSeek, that's at 70. Kimi K2.5 apparently beats Kimi K2.5. It's slightly less than Claude. The Claude still got the 77.5. Gemini 3 Pro, which was actually clever, according to some of my, coding tests that I like to do with the new lines here and there. That one actually got it right, and apparently it's better than that. So we're gonna test this out properly, and it's a general language model, so that means it should be generally smart at everything. So we're gonna be finding out what is good. I'm just gonna give you a little preview because I've been working on getting it to work, and I had to do some tests and figuring out the right quantization to use and all that stuff. So I've been working on all that. And to start off with, this is GLM 4.7. This is making like an art exhibition Earth kind of demonstration. As you can see, it looks gorgeous. This is a very, very good demonstration. You got shadows, you got lighting, you got the stars, you got absolute beauty. Now, this is GLM 5. This is the first quantized version I did of it. I did a mixed one between 4 bits and 6 bits just to get as much as I can into a Mac Studio. So it's using 400 and so gigabytes of memory. The second version I did was, this is a mix of 4 and 6 again, but I've changed some of the weights, some of the layers, I've increased them, made them slightly better. So this is actually very, very beautiful, in case you don't know, because this is the same as this guy, except it's got maybe more lighting than it. And the only difference really is this one doesn't have a texture, and this one has a texture of the Earth. So if you stick the texture of the Earth onto this version, it's going to be better because you've got all these like UI on the sides. It's got Earth in a different text. It looks a lot more meaty. The only thing that's missing is the texture. I bumped it up a bit more. This is going for a mix between a 4-bit, a 6-bit, and a 9-bit. Just playing with the layers. Gonna get a lot more intricate with this stuff. And this one is also more beautiful than the last one, because look at that, it's got a little star in the background there twinkling away. And this one here, it also has a star, but you can see it's a square. So we upped the intelligence on this demonstration, and look, it's got different text over here, so it looks better. Now this one is a mix between 4 bits, 6 bits, and 16 bits. I was going crazy trying to find out the best quality, and it is actually very, very beautiful, except the Earth is transparent. So I couldn't release this one. So the one I went for is the 469, and just comparing it to Kimi K2.5, since we talked about that, the same prompt gives you this. This is using MHA, the multi-head attention, and that uses this prompt, and the context of this took over 10 gigabytes of memory. But it's cool, you can like click on Mount Everest. It's got a little pointer you can click on the screen. So I switched it up, and now we're using MLA, which is multi-head latent attention. And this one only uses 0.3 gigabytes, and it's pretty much the same demonstration. It's pretty much the same registration. Look, still looks beautiful, good. You can switch over to light, dark, and all that stuff now. According to the benchmarks, GLM-5 beats Kimi K2.5, and this is a 4.8-bit quant version of it. This one is only a 3.6-bit quant version, and it just looks adorable. It's gorgeous. But that was just a little bit of test just to get a feeler of what's going on. Let's jump into the actual inferencing. So I've got inferencer over here, and I've actually got GLM-5, the 469 8-bit version loaded into the studio. So let's just jump in and let's just do a speed test over here. So I'm going to limit it to 1,000 tokens. I'm going to say write a story, and we can see here that it's doing 18 tokens a second to start off with. So even though it's a lot larger, it runs at pretty much, if not faster than the older model, the 4.7 version. I was running that one at 6-bit. So obviously, you know, that's the sacrifice that we're making in the quality. But this one at the 4.8-bit, it runs about the same bit as the 6-bit. Now, is it going to be more intelligent because it has all those extra billion parameters? We're going to find out. I'm going to do some of the tests that we challenged it on before. When we finish this generation here, we've got 1,000 tokens and 16.5 tokens a second. Let's check out the memory footprint. Book 0.1 gigabytes, GIBs. 0.1 GIBs for 1,000 tokens. Our peak memory was 417.9 GIBs, and that is pretty good. So we got a nice, healthy, maybe 100, almost 100 more gigabytes of context window to play with on a Mac Studio 512. Now, if you guys have less than a Mac Studio 512, don't worry, because we're going to be pushing out some REAP versions of this model very, very soon. We're going to, you know, cut out some of the tokens, hopefully to kind of make it smaller. Let me know if you're interested in that. I'm going to get into this world and try helping as many people as I can out. So we got this, it's 1,000 tokens, and this guy also supports batching. So if you enable that feature here, and now that we've got MLA, the memory usage is going to be a lot less. So batching is definitely viable. And we got prompt caching coming in. This is going to be 1.10.1. We got prompt caching coming into batching, and that will mean that everything's just going to be amazing coming up. So let's just run 2 prompts at the same time to see what happens. So I'm going to run this guy now. We've got batching enabled there. So write a story. We've got 2 prompts running at the same time. They're going at 12.7 tokens a second each. So that's almost 20 above. It's above 25 tokens a second. We've got 2 at the same time. And if you keep on adding to it, if you got 6 inferences at the same time, you get over 30 tokens a second. So that is, if you got like kind of like a family computer or like a business when lots of people are just hammering your server, you can get multiple inferences going all at the same time with this model. But that was a bit of fun. Let's see now if the quality is any good. Like, this is write a story. This one's called Write a Story. So the rain in Sector 7, I heard this story a million times. Sit down, Elara. Yep, the same sort. So this is the same sort of story that you heard before on this model. I don't want to hear the ending. I forgot the ending. Very, very dramatic stuff happening over here in this world. But the first, since this is a general language model, before we jump into the coding stuff that you guys are all excited about, I'm going to go into its comprehension. So we're going to do some logic tests, and there's a new logic test going around on the Reddit, and it's actually a really good one. So I need to share it with you. I want to see if it's actually going to fail. I got thinking disabled, and this is a fun one. The car wash is only 50 meters from my house. I want to get my car wash. Should I drive there or should I walk? And it says you should walk. This is with thinking disabled. I'm going to give it another try. I'm going to allow thinking this time, and I'll hit play. And it's going for a reasoning model. Now, while it's doing that, let's quickly jump into the ChatGPT and let's see if that one fails. And you should definitely walk. Uh-oh, let's jump into Claude. Claudie. And you should also walk. So the big guys are also doing the walking situation. And the thinking of GLM is still reasoning about it. It's caught on that it could be a joke. Self-correction. Don't be condescending. Treat it like a valid question. In order to get your car washed, the car needs to be inside the car wash. Hey, that's good. The surgeon is the boy's mother. That's with thinking disabled. Let's enable thinking and see if that fixes it. So it's definitely going through the reasoning situation. While it's doing that, I'll ask it another one. Imagine a runaway trolley. Don't pull a lever. And that's with thinking disabled. So he understood that. Self-correction. If I just say the mother, I failed a logic test. If I say the father, I might look like I missed the joke, but I'm technically correct. The best response points out the explicit wording. It's got this extra new bit that I haven't seen before. Self-correction double check. So that's a new part of its reasoning chain of thought. You kill one person, the other guys are already dead. So it is passing these challenges, especially with thinking enabled. So that's really good. I'm happy with that. Especially that beat out the Claude in the shit GPTs. When I give this question to ChatGPT, it comes up with the wrong answer. Next up, I'm going to jump into my coding riddles. So I've got the regex one that we've previously done on this channel. I've got thinking disabled. And I'm also going to run it at the same time just to get these answers with thinking enabled to see if one of them gets it right. And I've got another logical puzzle. This one is all about asking it why is the text not taking up the full width of the view, and it's because I actually hard coded in some new lines, and only 2 models so far have gotten this correctly. It's Kimi K2.5 and Gemini. So I got thinking disabled, and I've also got thinking enabled. Let's see if it will do it. That is interesting. So GLM, they've actually got the regex correct. So they've replaced the K. The problem with this check was that it had hard coded either a K, an M, or a 0, but we were looking for a model that had _1, which isn't a K, M, or a 0. But it's got the right answer with thinking disabled. So in less than 1,000 tokens, it's actually got the right response now. GLM 4.7, that guy needed thinking on, and it took 6,700 tokens to get the right answer. But now, boom, we actually got the right answer already. GLM, are you guys watching my video? What's going on? I'm the only one doing these weird tests. Now, perfect. So thinking is disabled on the new line riddle. And we can see that it has suggested making the max width infinity, which is wrong because the issue is I've got new lines encoded. Now, I tried this out on ChatGPT. I tried this out on Claude. They both failed as well. The only one that passed it so far was Gemini Pro and Kimi K 2.5 when you put it in agent mode, or if you bumped up the experts. Oh, look at this. The thinking mode. It's on the hunt. It's thinking about it. It says it has new lines. So it'll be 3 lines regardless of width. All right, so it failed that one. I'm going to try bumping up the experts with this one because it had potential. It was definitely thinking about it. It just didn't rise to the top. You know, I think it might have actually figured this one out. Look at that. It's talking to itself. Bingo. Bingo. It's like one of these old age pensioners living life. I guess it's 5 years old now, so it's having fun. So look, 3 lines because new lines are string literal. So 3 lines because it's new lines, and it goes bingo. Solution is you align the block to the left, set to max width, and it's going to be as wide as the largest line, and hopefully it will stay in the screen. So this sounds like a good answer. Since your text contains new line characters, it forms a multi-line block. So that is just with more experts. We didn't have to go to many experts. So we got a 3rd model right now. Obviously you have to play with the number of experts. This is not an out of the box feature, but you do get it with Inferencer. So you just click on that and choose more experts and you get smarter answers. We proved it over there. That's pretty cool. Now, the next thing I want to test out is how it fares with tool calls. So I'm going to go and just enable tool calls. I've got some tools here. The one that I always have enabled is get web page content. So I can say something like, what is xcreate.com? And it should make a web call. It's going to go to the website. It made a tool call there. It's gotten the response of xcreate and it's explaining to me what it is. But I want to be more challenging now. So I'm going to go into Wikipedia. I'll say, how many employees does z.ai have? So it's gone to their website, making a web request. Boom, got the response there. So the content length that was given is only 8,000 characters. The total length is 16,000 characters. So it's going to pass the 8,000 characters. If it has the information, it should tell me the response. If it doesn't have the information, it should make a second tool call to get the next page of the results. And it's actually got the information of their 800 employees. So that's good. It passed that test. That was cool. Let's give it a harder test because we want that multiple tool calls. Go to Wikipedia, Tencent, and tell me how much ownership they have of Wangyangshun Xingtang. It's made a tool call to Tencent. It's got 8,000 tokens. Memory usage wise, we're 460 gigabytes is my total system. Inferencer itself is only using 420 gigabytes. So we still got like 80 gigabytes plus to play with of context window. And because we got now MLA, our context is very small. So we're going to be loving this model for long context stuff, especially with the prompt caching stuff now. So yeah, it's going to be good times ahead. We're going to be doing some, oh, look at that. So it's made a second tool call, and you can see that the start position it shows is 8,000. So it's got 8,000, it's got another 8,000 results. It's getting the 3rd page now. It's gone to 16,000. So it's definitely flowing through this website. Very smart model. I like that. Oh, look at that. It's got the right answer. 20% stake. The current stake is apparently 94%. I didn't even see that. It did some thorough research. Let's see. Look at that. Increase to 94%. So it's got the right answer. Good job. That's good. That's good for two calls. So when you run it through your OpenClaw and your coding agents, it's going to be very, very smart because it handled that challenge. Some models I've ran it with didn't actually do too well with that. So everything seems to be working nicely with this model. Now to finish off this episode, before we jump in and run it distributed compute, that's right, we're going to be building an even higher quant version. We're going to run it with our Mac Studio, with our MacBook Pro to get a higher quality version. Stay tuned for that on the next video. But before we do that, I just want to do one test, maybe two, maybe three tests. I'll do some coding exercises just for fun. I'm going to have thinking disabled. I'm going to turn batching on, make sure that's on. Flappy Birds 3D Minecraft 3D solar system. And someone actually asked me to see if he could make a Tiddlywiki clone. So let's see what happens here. We got 4 inferences banging it on, doing some coding. And what's cool about it is, even though we got massive context windows going to be built, I'm guessing 5,000 tokens each, it's gonna handle it within our Mac Studio, and it's hitting it 7 tokens a second each, and this is definitely going to be the smartest coding model. And as you can see, around the midway point, 2,500 tokens produced, 1,000 here. We can see our memory is still only 435. So yeah, we still got plenty of space with all of these rocking away. But don't forget, coming soon as well, if you are struggling for context, we got a precision option over here, so you can quantize the actual context as well to get more memory for your context window. All right, we're back and thousands of tokens were produced, and as a refresh, this is GLM 4.7, the 6-bit version of Flappy Birds, and that looks gorgeous. Got to say, it's a bit hard, but that is gorgeous. So let's just see how GLM-5 has done. And what is this? This is the future of Flappy Birds. So you press space or click to fly. Oh, this is cool. That is very stylish. Play again. It's still hard. I've got a bit of bugs there on the UI, but it's definitely... I did one. I'm happy with that. I did one. So that was the nice explosion. This one's maybe it's a bit basic, isn't it? Nothing happens. And this is the 6-bit version. This is the 4.8-bit version, and we got special effects, bit bugs, but this was even with thinking not even enabled. So gotta say that's improved. Yeah, what do you say? I think that's an improvement. Voxel World, this is GLM-5. Let's see what we got. Okay, we do have, it's slow. It's a bit slow. There's no gravity. I'm just going up in the air. Can we select on the menu? So we've got some menu selections here. Can we interact? Okay, it's not the best version of Minecraft. I think it's got lots of potential there. There's textures. Some of the models have made Minecraft, but without textures. This one has textures. It just doesn't have gravity, but it's got potential. Frame rate is 22 frames a second. It's got 11,000 blocks. So maybe I can prompt it to say, hey, can you do an optimized version? There's lots of potential for it there, but at least there's no runtime errors. So that is good. This is a good quality version of the model. This is the 3D solar system. This one is GLM 4.7. So this is making a 3D solar system. Now there are actual planets. You just can't see them. Yeah, look, there's a planet right there. You got to be very, very careful to see them. So there's little planets. You might notice it, but this is GLM 4.7. Look, there's a planet flying around. And there's no one there. So there are planets, but this is GLM 4.7. Let's see how 5.0 did. And ooh, it's maybe you can see the planets this time, I guess. Maybe that's a bit basic. I did like the bit of the color of the sun here, a bit more basic here, but you can actually see the planets. So that is an improvement. So even though we've got a lower quant model, it is definitely a better result there. So that's beautiful. That's beautiful. I like that. And finally, Tiddlywiki. Unfortunately, that one has a runtime error. Oh, look at that. It's got a little runtime error. So syntax error. You can probably just feed this in and it'll probably fix it. I'm tempted to just do that. There's a lot of AI conscious people. I was saying, no, you got to give your AI another chance. It's unfair that you just do one shots. I'll do one shots because, you know, today it might not work, but tomorrow the next model is going to be one shot and it's all going to work. So it's got a fix. It uses basic. So potentially, yeah, we got an answer. So you can just continue on and play with it. So next up, I guess we can check out the OpenClaw, the agent installer. Maybe I'll save that for the next video where we hook up this GLM to a Mac Studio and MacBook Pro to get a higher quant version. How much smarter can this bad boy get? But let me know what you guys think of z.ai's general language model. Is it generaling it about? I think it is so. And one thing you just gotta respect these guys for, this is MIT license. This is a very, very like open license. You can just grab the weights and do what you want with them. Some models, they require you to, state attribution, which is still, the least you can do really. But these guys just say, hey, just take it. Just take it, MIT. So let me know what you guys think. Hope you guys found this video useful and enjoyed the show. Now let's fire up the clue.